Hey guys, welcome to another episode. So it's a bit of a longer video today, but it's definitely gonna be worth your while, so stick to the end. We're gonna take a traditional model in Excel and transform it, convert it to a Monte Carlo simulation. Monte Carlo simulations are an amazing way to take care of uncertainty in our models, and gonna show you exactly how to do it step by step. We're even gonna write a small macro that's gonna run the whole simulation for us. By the way, if you enjoy those videos, I would tremendously appreciate a sub and maybe even a thumbs up if you enjoy the video. Let's get straight to it. Okay, so we have here this simple model where we have our sales volume, sales price, cost of sales, and our option for tax exemption. And I've went ahead and calculated the traditional approach. So let's look at what we have done. Our sales volume is, so it's going to be minimum 25,000, most likely about 40,000, maximum 45,000. And for our traditional model, we would have gotten the most likely. Then our sales price, we have a min and a max. So I just went ahead and calculated an average. And for our cost of sales, we have our mean, which is the expected, and our standard deviation, taking the expected here. And for our tax exemption, there's 70% chance that we're gonna get the tax exemption and 30% chance that we're not gonna get exempt, so we're gonna have to pay 35% tax. And we use a decision tree formula here, so basically, we get the probability multiplied by the outcome plus the other probability multiplied by that outcome and multiply it on to our profit. And this is our traditional approach that we would usually follow when calculating this model. What happens if we want to apply a Monte Carlo simulation? So the first thing we need to do is gonna need our distribution types here. Okay, so this is a triangular distribution. We have a min, a most likely, and a max. This here is a uniform distribution, so min and max and everything is exactly the same probability of occurring. This is a normal distribution, and this is a discrete distribution. We have a list of options. So it can either be this or this, with those probabilities, and it can never be like 25 or something like that. Let's go ahead and calculate some values for those before we build our Monte Carlo simulation. So here we'll need to set our min, our most likely, and our max. And I'm gonna add some borders to those. So our min, just link it from here, most likely, and our max. And then for triangular distribution, there's no formula in Excel, so we have to calculate it on our own. We have a lower range, a higher range, we have our total range, and our cumulative probability, which is actually our random. Let's just format those as well. Our lower range is gonna be, let me just carry over here some formulas for the triangular distribution because it's a bit harder to do. So here we have our triangular distribution random number generation. So our lower range is our mode, so our most likely, minus our minimum. Our higher range is our maximum minus our most likely. Our total range is our maximum minus our minimum. And our cumulative probability is just going to be the random number between 0 and 1. Let's just go ahead and calculate it here for our model. I'm just going to carry all the formatting from here with the format painter, and this formula I'm gonna carry over my profit, I'm gonna carry over my cost of sales, I'm gonna carry over, and my net profit I'm gonna carry over. You notice that every time we save or edit a cell or press F9, we recalculate the random numbers, and this is what we're gonna use for our Monte Carlo simulation. We're gonna run it over and over, and every time all the random probabilities are gonna recalculate, and we're gonna get a different result here. This is the formula that we have to write. It's a bit hard to comprehend, but let's just type it in. So we need to check if the cumulative probability, so this, is below the lower range over the total range, and then our random triangular is equal to our minimum plus the square root of our cumulative probability multiplied by our lower range multiplied by our total range. And if it's not, else our random triangular is our maximum, so our max minus the square root of 1 minus our cumulative probability multiplied by the higher range now multiplied by the total range. 1, 2. Okay, that's it. And the easiest way to check if we've written our formula properly is that if our cumulative probability is 0, we need to get 25, which is the minimum. And if it's 1, we need to get 45, which is the maximum. So our formula is correct. Okay, I'm gonna go ahead and get rid of this. And let's go ahead and continue with our assumptions below. So for our uniform distribution of sales price, we'll need our min, our max minus min, and a random number again. Just gonna copy this random from here and carry over this format. Okay, so our minimum is 8, our maximum is 850, and our max minus our min is 50. So the way we're gonna calculate this is we're gonna get the minimum and we're gonna add our random between 0 and 1 multiplied by our max minus min. So basically if our random is 0, we're gonna get 8. If our random is 1, we're gonna get 850. Okay, and now we have our sales, and you see that every time we press F9, our sales change. Cost of sales is gonna be our normal distribution. So in order to calculate this one, we need our mean, our standard deviation, and a random number as well. Okay, so this is our mean and this is our standard deviation. And the way we calculate this one, we're going to use the inverted function. So basically it's going to be our min plus norm s inverted. So this returns the inverse of the standard normal cumulative distribution. Inverted, this is our probability, so our random multiplied by our standard deviation. Okay, and what's left here? We have our tax, our discrete, so have 0.7 chance and 0.3 chance, and just grab that random over here. And this is at 0.00% and this is at 35%. The way we're going to calculate that is we're going to see if our random reaches up to 0.3, it's going to be 35%, and if continues above that for the next 70%, it's going to be 0. So if our random is less than is here, oops, give me 35%, otherwise give me this 0 multiplied by our profit. Okay, and now you can see that our tax is 0, and if we keep pressing F9, at some point we go into this 0.3 probability and we have a 35% tax. Okay, so that's our Monte Carlo model built here, and now let's see how we can run a simulation. So I'm gonna start building it here. We'll have our counter. This is where we're gonna write in how many calculations, how many iterations we want our model to run for. So let's start with 500, and here we'll have our iterations counter, our average result, and our probability of it being above 120,000 and 150,000. Those are the two checks that we want to do. So if it's above that, we want to consider the project, and if it's above that, we're definitely going forward with the project. Okay, and the next thing we need is a list of our iteration and net profit, or profit after tax, let's just call it net profit, that we're gonna get. Okay, I'm gonna grab that formatting from here, and our iterations is gonna be just a count of all our net profits. The average is gonna be the same, the average of all those, and our probability above, we're gonna do it with count if. So count if, and my just up here, my criteria is going to be above 120,000. Okay, and I'm going to copy the formula here, paste it here, and just switch to 150,000. Okay, now how are we going to do that? The idea is that we want this to change as if we're pressing F9, and every time it changes we want this figure to be copied here and going down. But one way to do that is by hand, so pressing F9 and copy pasting, but we usually run hundreds and even thousands of iterations of each simulation, so that's probably not the best idea. What we can do is we can go ahead and write a simple macro to do that for us. Okay, so just gonna go to the developer tab, insert, gonna grab a button, put it over here, and I'm gonna call that Monte Carlo sim, and create a new subroutine. So this is our subroutine. This is the Microsoft Visual Basic for Applications editor, and let's just go ahead and write our macro. So what we want is we want a loop that's going to run through our iterations. So for I'm going to call it iteration, and it's going to be from 1 to cells row index 5. So I want to be getting this here, and this is my 5th row, and M is my 13th column, so 513, and this is going to iterate from 1 to 500 or whatever we type in here, and every for loop needs to end with the next iteration. So it's gonna go from iteration 1, then run everything in between those lines that we're gonna input right now, and go all the way to 500 before ending. Okay, so what we wanted to do, we want our cell, so my iteration heading here is at the 12th row, so I want it to start from the 13th row. Just gonna type in 12 plus iteration, because our iteration is gonna be 1 at the first run, and then it's gonna grow, so it's gonna move the cursor down and copy on the next row every time. M is at 13, and here I wanted to place my result, my net profit, and my net profit is at my 31st row, and at my fifth column. So A, B, C, D, E, my fifth column. So 31, 5. And every next iteration, it's gonna copy this result in the next row down. And also wanna have my iteration index. So once again, on 12 plus iteration, 12, because L is my 12th column, give me iteration. And that's our subroutine, that's our macro. Let's just save that and just name that a bit more appropriate. Run simulation. And now the only thing that's left to do is go ahead and run it. Let's first run it for 100 iterations just to see how it works and if it works properly. And let's go ahead, run simulation. Okay, we have some issue. Okay, let me just see if we assigned the proper macro. Actually, I'm just gonna reassign it. And now it should work, yep. Okay, and that's it. You see, just for a few seconds, we already completed our 100 iterations. And you can see that the average that we get is 120,000. And here are all the results from all the iterations. This probability here doesn't seem okay. Yep, we've forgotten something. We just counted the instances, and in order to get the probability, we have to divide them over our iterations. Divide over our iterations, and those need to be formatted like so. Okay, I'm gonna go ahead and run this for a bit more just to see if you see that the average now is 121,000 and the probability about it being above 120,000 is about 50%, and this is about 22%. But 100 iterations is quite a few, so let's just go ahead and try to run it for about 10,000. Okay, we've run it for 10,000 iterations, and you see that our average dropped a bit, but this is probably enough iterations. 10,000, if you noticed, like maybe after 5,000-6,000, it rarely moved from those probabilities, and the average pretty much stuck at 113,000. So we can consider 10,000 iterations enough, and 100 wasn't enough. It gave us a bit of a misleading information. What we can see here is that the average is 113,000 that we're gonna get, and this means that our probability of it being above 120,000, what we want, is only 40%, and about 150,000, just about 16%. And you can see that our traditional method here showed us that we're gonna get above 120,000, which was a bit misleading, because once we run our Monte Carlo simulation, you can see that the possibility of that is only about 40%. So we have to figure out if this 40% is enough to pursue this project. Okay, that's how to run a Monte Carlo simulation. You can do that for as many assumptions you want. With there's tons of different probability distributions that you can apply to different assumptions. Okay guys, that was it for this video. Monte Carlo simulations are amazing, and they can help us a lot in any kind of modeling situation where we face uncertainty. So I hope you enjoyed the video. Give it a thumbs up if you did. Also, don't forget to subscribe if you're not already, and maybe even punch that bell icon to receive notifications every time I upload a new video. Till then, thanks for watching, stay safe, stay at home, and see you in the next one.